This is Module 4, Trigonometric Ratios. In this particular module, you're going to be learning about the three trigonometric ratios, which are probably one of the most important things that you're going to be learning for not only geometry, but also for higher level mathematics as well. So, trigonometry is actually the study of the relationship between the sides and the angles of triangles. And what was figured out is that there's an actual common ratio between what angle is created and the side length that is opposite those particular angles. So if I have an angle A given in a right triangle, we can call the opposite side of A is, you kind of think of it like A's angle is a mouth, and for example, the yellow part here, that's a mouth, and that would be eating the opposite side. So that is going to be our opposite side. The other part you need to know is the adjacent side. Adjacent means next to. So opposite, adjacent, and then the right angle, opposite the right angle is always going to be your hypotenuse. That's what we basically have been studying throughout all of these modules. In order to do this part of the chapter, you need to know what the opposite side is versus the adjacent side versus the hypotenuse. The hypotenuse is always going to stay the same, but the adjacent side versus the opposite side will change given the angle that I ask for, or the angle that I give you. So here's our first round of trigonometric ratios. And I have my triangle up here. That has, again, my A angle that's given here. So we have our opposite side here, we have our adjacent side, and opposite the right angle is the hypotenuse. The trigonometric ratio is a ratio of the lengths of the two sides in a triangle. So you're going to take the ratio of two of the sides of the triangle. So the first one is sine. And we say sine of A, and that's always going to be whatever your opposite side length is over your hypotenuse's length. Cosine is going to be whatever your adjacent side length is over your hypotenuse. And then we have tangent, which is opposite side over adjacent side. So sine, cosine, and tangent. The way you remember this is it's SOHCAHTOA. So you have sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. SOHCAHTOA. So that's the best way to actually remember it. Alright, so I have my triangle here. We're going to get a little bit of practice with this. So it's asking for, the first one, sine of C. So that means you have to identify and say, okay, this is the angle that I'm working with. If you know, and you remember in the previous slide, SOHCAHTOA, you will know that sine is whatever the opposite side length is over the adjacent, or I'm sorry, over the hypotenuse. And in this case, I should add a right angle here. So opposite over hypotenuse. So the opposite, the one that the C angle is eating, is going to be side P, and the hypotenuse is going to be R. So it would be P over R. For cosine of C, you do the exact same thing. Cosine is going to be adjacent over hypotenuse. So if you want to start writing, if this helps you, what your opposite is, what your adjacent is, and then your hypotenuse, just make sure when it asks you, if it gives you a certain letter, you stick with the labeling of that certain letter. But for example, like down here it has cosine of A, that means you'd have to change the opposite and the adjacent to make sure that you satisfy cosine of A. But again, let's go ahead and continue with C. Cosine of C is going to be the adjacent side, which will be T, over the hypotenuse, which is R. Okay, so it's going to be T over R. What about tangent of C? Again, look at your SOHCAHTOA. We know TOA, tangent, is opposite over adjacent. So I know my opposite is going to be P over my adjacent, which is t. Now, since we're changing and we're going to cosine of a, what I'm going to have to do is I'm going to have to change the labeling, because now I'm dealing with angle A, not angle C. So once I do this, I have angle A. Now my opposite is going to be actually the side T. So this one here is going to be your opposite. This one here is going to be your adjacent. Your hypotenuse still stays the same. So in terms of cosine of A, you want adjacent over hypotenuse. So adjacent over hypotenuse would be P over R. Now what about sine of A? Again, you go back to your SOHCAHTOA. So sine is opposite over hypotenuse. So opposite would be T's length over hypotenuse, which is R. Last but certainly not least, we have tangent of A. So tangent of A is opposite over adjacent. So we have the opposite, we have the adjacent, which would be T over P. And you're done. Here are some more examples. So I have sine of A, so I label what my A is, and if you want, if this helps you, you can do this guy here is your opposite, this guy here is your adjacent, and this guy here is your hypotenuse. I'm going to do this for the first one, then I'm going to go through a little bit more quickly, just to make sure. Because you do not have to actually do this for each one of them, it just kind of helps sometimes when you're first starting out. So, in A, sine would be opposite, which is little a, over hypotenuse, which is little c. Okay, so once we have that, then we can do the exact same thing for cosine. Cosine, my adjacent would be b over my hypotenuse, which is c. Tangent, now we're looking at tangent for b. So tangent for b, again, since we have an opposite orientation, that means we have to switch these guys. What I'm going to do is I'm just going to kind of do it off of intuition. So looking at B, this is what we're looking at here. My opposite would be little b over my adjacent, which would be little a. Now sine of J. Sine of J, we're looking at this angle here. Opposite over adjacent, or I'm sorry, opposite over hypotenuse would be little j over L. Then we have cosine of K. Cosine of K would be adjacent, which would be little j over L, again, your hypotenuse. So adjacent over hypotenuse. Tangent of K would again be opposite over adjacent. Opposite would be K. Adjacent would be J. So let's actually apply some theory to this. So in a right triangle, what I give you, it says find the value of x to the nearest tenth. The main thing you need to make sure of before you start with this, your calculator needs to be in the mode of degrees. Should read DEG. So it depends on the calculator, but you can look it up if you do not know how to actually change it into mode of degrees. But if it's not in the mode of degrees, you will get these incorrect, even though you're plugging them in correctly. So what I first have is I'm trying to find the value of x. So value of x here, and what we know, what we are given, is this angle here. In relation to this angle, we know this guy here, which is your opposite, and the x in relation to 59 is going to be your adjacent. Okay, so you have opposite and adjacent, which means if you're looking at SOHCAHTOA, the only one that has opposite and adjacent is tangent. So that means I'm going to use tangent of whatever degree measurement you're given, which is 59 degrees. That equals your opposite, 17, over your x. I always put my tangent, sine, cosine, and tangent over 1, because once you do this, the way you do it, the way you solve for x, is you can cross multiply and solve. So cross multiplication, and this will occur in every single one. So when you plug this into your calculator, the thing you do first, after you've made sure that you are in degrees, is you plug the tangent button and then 59 degrees. And if you calculate this, you should get tangent is equal to 1.664, and I'm going to round it to the nearest fourth, over 1 equals 17 over x. Cross multiply, solve, we get 1.6643 times x equals 17. If I do 17 divided by 1.6643, that will give me approximately 10.2. So that is going to be my length of x, is 10.2. And I just used trigonometry to actually solve for an unknown value. So, you can pause the video and try number 2 on your own, or you can continue along as I actually go through it. So here is number 2. So number 2, we know 26. In relation to 26, we know opposite. So 7 is going to be your opposite. X is going to be your adjacent. Once you know opposite and adjacent, you look, we're actually using tangent again, so you can set it up. Tangent of 26 over 1, remember to do the over 1 so you can remember to cross multiply, is opposite, which is 7 over x. First evaluate what tangent of 26 is. So plug into your calculator. Tangent of 26 should give you something close to 4 or 0.4877 if you round it to the 4 decimal places. Okay. Once you do that, again, cross multiply and solve. We got 7 is equal to 0.4877 x. You do 7 divided by 0.4877 in your calculator, and you should get something approximately 14.4 if I round to the nearest tenth. And that's our value of x, 14.4. Okay, third example. It says find the length of the hypotenuse of a right triangle if an acute angle measures 20 degrees and the side opposite the angle measures 410 feet. So, first thing you have to do, hypotenuse of a right triangle, is draw the actual figure and label what you know. We're trying to find out the length of the hypotenuse. So, the length of the hypotenuse, there's h. So, the thing you have to ask yourself is what parts of this triangle do you know in relation to 20 degrees. So what I see is 20 degrees, opposite the 20 degrees is 410 feet. Then what does the h act as? That's your hypotenuse. So you look at SOHCAHTOA. I have opposite, I have hypotenuse, so that automatically means I'm going to be using sine. So you set it up. Sine of 20 equals 410 over h. Plug in sine of 20 into your calculator. You can also cross multiply and then plug in sine into your calculator. It's up to you. But once you do this, you should get roughly about 1,199 feet. And that's it. Okay, so problem solving with right triangles. The angle of depression of an object lower than the viewer is the angle with its vertex at the viewer's eye, one side horizontal and the viewer's line of sight to the object as the other side. So angle of depression. So here's an example. I have a little guy that's standing on a pedestal and he's looking at a guy in a race car. Here we're going to actually apply angle of depression. So it says find a hypotenuse using an angle of depression. You are skiing on a mountain with an altitude of 1,200 meters. The angle of depression is 21 degrees. About how far do you ski down the mountain? So, my angle of depression is 21 degrees. I have what I'm trying to find, the length of the mountain, distance down the mountain, and I have my 1,200 feet. So the thing you have to do is you have to see what 1200 feet are and what x are in relation to 21 degrees. So how do you do that? You have to write sine, because in here you have opposite, that's your opposite, and then you have your hypotenuse. So we are going to be using sine. So sine of 21 degrees equals opposite over hypotenuse. We're going to substitute what our opposite and our hypotenuse are, which is 1200 over x. We can cross multiply or evaluate your 21 degrees first and then cross multiply, but it's up to you. Once we do that, you can divide by 21 degrees, sine of 21 degrees that is, and then evaluate, and you should get roughly about 3,348.2 meters. Getting used to feet. But again, you establish what trigonometric ratio you're using. In this case, we use sine. Set up the ratio, set up the proportion, and cross multiply and solve. Okay, just like angle of depression, we also have something called the angle of elevation. So the angle of elevation of an object higher than a viewer is the angle with its vertex at the viewer's eye. One side horizontal and the viewer's line of sight to the object as the other side. So I have a little stick figure guy. He's looking at the top of a pine tree. So that would be an example of angle of elevation. So let's actually apply angle of elevation. So we have the angle of elevation from a sailboat to the top of a 121-foot lighthouse on a shore measures 16 degrees. So there's my 16 degrees. We know that our lighthouse is 121 feet. To the nearest foot, how far is the sailboat from the shore? So what are we trying to find? We're trying to find the distance from the sailboat to the shore. So that's our x. So you establish what you need to know. What you need is in relation to 16. So what I see is I see 121 is my opposite, and I see that x is my adjacent. So that means automatically I have to use tangent. So I use tangent 16 degrees equals 121 over x. This here, you can cross multiply. You can evaluate tangent of 16 first and then cross multiply and not have to deal with the ratio, or the trig. You can get it over and done with, or you can just cross multiply and kind of treat tangent as an x and move it from left to right. So in this case, I cross multiply, then I'm going to divide both sides by tangent of 16. And when I do that, I should get roughly around 422 feet. So, as a recap, make sure when you are doing these, your calculator is in degrees. In other courses, you are going to be using the radians mode. But in this course, you're going to be needing the degrees mode. And I will try to remind you throughout the modules as we go along.